Mm-hmm. Según yo, sí. Sí. Ok. Sí, sí, lo entendí. Este es el puntero, ¿no? Y arriba y abajo. Perfecto.
Main challenge during all the course of the talk. Both to respect our speaker, but also so we can hear about it. If you need to get out of the classroom before the talk is ended, we suggest you to leave quietly. Today we have Dr. Erika Bustos speaking us from CDTech. Dr. Erika Bustos is a distinguished researcher in environmental electrochemistry, recognized for her contributions to scientific innovation and sustainable development. She holds a PhD in electrochemistry from CDTech, specializing in modified electrodes, a thesis that earned 3 national awards. She also obtained a Master in Science in Chemical Sciences from the University of Guanajuato and a Bachelor in Science in Environmental Engineering from the National Polytechnic. She completed her postdoctoral research at the Staff Laboratory in Chemistry, and currently Dr. Bustos is a full professor researcher at CDTech, leading research on modified substances for detecting and transforming environmentally significant molecules, water, soil, and air. Her work involves international collaboration with Hungary, Spain, Italy, Colombia, the US, France, and England. And she is a National Researcher Level 2 and a regular member of the Mexican Academy of Sciences. Dr. Bustos has received numerous prestigious awards, including the L'Oreal UNESCO AMC Award in 2023 and the Mexican Invention Award in 2021. She has mentored numerous students and contributed to scientific outreach and intellectual property development. Please welcome Dr. Erika Bustos with a big applause.
Thank you. Thank you so much. Thank you so much. I am very happy to be here. It's my first time in Arkansas University. Thank you so much to Diego for his kind invitation and Liliana, who followed me in my stay here. Well, the idea of this presentation is to show you the different projects that we develop in CDTech. CDTech is a center, a public national center. The idea of these centers is to involve the society, the industry, and of course, the knowledge across the academy. We have 4 postgraduate programs, a master and PhD degree in electrochemistry, and other master and PhD in environmental engineering. Well, they are some for us of the different laboratories that we have in CDTech. We work here like researchers, and we collaborate with different engineers when we develop some pilot systems. And additionally, we have other laboratories focused on service, because fortunately when we have a big projects, we involve the different areas in CDTech. They are my colleagues. We are in the research group in water and environment. So the idea of this talk is to have in mind that actually increase the different temperature in the different countries and of course in the world. The problem is the different pollutants that we generate with the different activities, anthropogenic and natural pollution. So the problem is that when we generate a huge concentrations of the different chemical species, we generate that pollution in some specific places. And additionally, the transmission of this pollutant in the different matrices in the environment and the interaction between them increase the problem. So actually, that's why we have the ecological imbalance, and that's why we have the climate change. So this is, we can recognize the different temperatures during the day. Here, maybe sunny, in the other country, a lot of water. So the idea is to have a balance and to have in mind how to integrate the different wastes like a resource. If we involve the different wastes like a resource, we reduce the economic, social, and environmental negative impacts. So that's why maybe you know about that these different 17 Sustainable Development Goals. They established after 2015, and the idea is to eradicate poverty, protect the planet, and ensure prosperity, more for the new generations like you. So we involved with different matrices, and the idea is to have more resources and change of the linear economy to the circular economy. In the some years before, we have in the middle, we integrate the different processes with the recycled economy. But now we need to think about how to include the different resources in the different activities and different processes for the different matrices. So with this idea, if we develop the different activities since our laboratories, in the new activities or new relations, we force the Sustainable Environmental Goal number 12, related with responsible consumption and production. This is the best cartoon related with the circular economy. I recommend you to verify in the internet. There are different free information. And this is related with the Helen MacArthur Foundation. And the three best ideas related with circular economy is to have circular fountains, waste recovery, and products as a service. Here is when we include the different activities with the wastewater treatment, the treatment of polluted soil, and the treatment of polluted air. Maybe when you are young, when you are kids, you maybe usually listen your parents comment about how the recycling or how to reduce the different wastes. Now we have not only 3 R's, we have 8 R's related with recover, recycling, rethink, reduce, reuse, repair, recycling, rot, and included all of them in the different processes. This is our main motivation. But how we connect the electrochemical processes with a circular economy? Well, when you study electrochemistry, we need to comment about the electrical conduction across the different surfaces. Actually, we have a large quantity of plastics, but we can modify with nanoparticles to produce an electrical conduction. This is the idea of one of surfaces. We have different atoms, for example, iron or aluminum. They are common in the different wastes. And if we expose this kind of surfaces directly to some matrices, in general, the organic molecules arrive over these surfaces and reduce the interaction of these atoms with the matrices. Additionally, if we have a difference, a change in the pH, depends on the matrices, we include the interaction of different anions or cations included and interact with these organic molecules. That's why we promote that modification of these electrical conductors, these electrodes, and we promote the different chemical and electrochemical reactions and study the different interfaces close to the electrode and the different matrices. So we study and characterize the different surfaces with spectroscopy, microscopy, chromatography, electrochemistry. And the idea is to have more life of this kind of surfaces, and the different pollutants arrive directly to the surface, develop the different reactions, and the products of reaction return to the matrix. With this idea, we have better surfaces to remove the different pollutants. And we, in general, in the different projects, we follow this way. First, we design the surface. We verify which kind of different chemical compounds we need over the surface. Later, we construct the surface. Later, characterize the different surfaces and to go to the application. So with these ideas, well, the idea is to include circular economy and involve the goal number 12 and number 13. That is 13 is related with climate change. And which are the different applications that we develop in our laboratory? Well, we focus in the three main matrices in all the different environments: water, soil, and air. In the first case, where every year we have the different projects to reduce the wastewater or eliminate pollutants in the wastewater. That's why it's important in all the world, not only in CDTech. And we support with this line of research the objective number 6 related with clean water and sanitization. When you verify, you can find this kind of cartoon, and this is related with El Salvador. El Salvador established this kind of circular economy related with a wastewater treatment. And the most important is to reduce, recycle, recover nutrients and energy from the water, reduce efficient use, and restore water to the ecosystem. So this is a general idea of the wastewater treatment that we use in the different plants in different countries, and we have three main steps. The first one is to reduce the different solids that the wastewater have, because sometimes you can find wheels, you can find chairs, different big things. Remove all these solids from the wastewater. Then we remove some suspended particles inside of the water. Later, we introduce the flow directly to the biological processes. Here, you can use the anaerobic or aerobic processes. The idea is to reduce the organic matter from the water, to continue and separate the different sludge, which we can reduce in other activities. And finally, we have or develop that third step. The third step, we can include the different electrochemical processes. And here we have the experience to remove organic compounds. Phenol, chlorophenol is very common in different pigment industry. Hydrocarbons for the refineries. And the last one, the pharmaceutical products. These pharmaceutical products increase the intention to remove it after the pandemic situation. So the problem of these pharmaceutical products is maybe in your homes, in the clinics, in the hospital, generate in the different wastewaters a few quantity of the pharmaceutical products. But these pharmaceutical products is not eliminated during when you use this kind of wastewater treatment. So the idea is to destroy directly when you generate the wastewater. With this idea, well, Moises is one of the students who developed a process including ozonolysis, electrocoagulation, and electrooxidation. We developed the different processes and construct these diagrams, which were simulated. This is a software, very nice, the GPSX. And you include directly the different physicochemical parameters. And with this software, we demonstrate that it's a good idea to involve first the electrocoagulation, remove the organic matter. Later, we use the electrooxidation to destroy the pharmaceutical products, and in the end, the ozonolysis to help to increase the quality of the wastewater. Some of the results that we are, we published, increase the removal efficiency of the total organic carbon and the chemical organic demand. They are two important parameters in the different laws in all the world. And when you verify these parameters, indicate that you reduce the organic matter and continues to use this flow. Additionally, one of the ideas is to use other software. This is the COMSOL multiphysics. And with this software, we verify how was the difference diffusional transmission of the pollutant when we compare two kind of electrochemical reactors. In the first one, we include the electrodes in the horizontal position of the vertical transmission or diffusion of the flow. And the other, we include in the same way the electrodes they were concentric of the electrochemical reactor. And you can see here how in the last one, the parallel flow, we didn't retain any of the pollutants and any of the different physicochemical compounds. With this simulation, we have the idea to construct this kind of reactors. This is commonly, if you visit our laboratory, you can see this kind of reactors. And we use it flow with 24 liters. It's useful for to construct some treatment directly to go to the clinics or to the hospitals. So additionally, as my presentation, the title of my presentation is to involve modified surfaces. You can see here how we construct these surfaces, including iridium dioxide and tantalum pentoxide. The iridium is the electrocatalyzer to remove the different organic molecules, and the tantalum pentoxide is important to promote the protons close to the surface. When we promote the different protons close to the surface, generate more oxidant agents like hydroxyl radicals. It's very important actually in the different treatments. And the most important was that we compared two methodologies. The first one was painting the electrode, and the second one, we used the electrochemical, promotes the electromigration of the ions over the surface. And we organize more all the electrocatalyzers over the surface. And you can see here two graphs. The first one is how increase the removal efficiency of the total organic carbon when we use the electrophoretic deposition in comparison of the painting modification. The other one is how we reduce the concentration of the chemical organic demand and increase the efficiency when we use the same methodology of the electrophoretic deposition in comparison of the painting deposition. This was very important because when you buy some electrodes in the other countries, usually the technique is a painting modification. And we are electrochemistry, that's why we use the different techniques. And in this case, we include this methodology and increase the efficiency. So actually, we are working with the University of Castilla-La Mancha in Spain, with Professor Javier, and Adrian developed different surfaces involving waste. This is very nice because this is some plants that you can find in Castilla-La Mancha, and they are only waste in the city. So they prepare active carbons with this waste and promote the modification of electrodes, in this case, in the cathode. So with our anodes, base iridium, we use both electrodes to increase the efficiency of the removal of the pollutants. Yeah, well, we use amoxicillin is a modern molecule in pharmaceutical products. And you can see here how increase the removal efficiency of the amoxicillin in less time in comparison, in this case, using the Paramagnetis australis in comparison of the Spergularia rubra. So it's very nice because we reduce the waste in the city, but we use it to remove pharmaceutical products. And we verify actually the different laws in all the work. It's necessary to include that toxicity evaluation. So it's usually that you can use Vibrio fishery to evaluate the toxicity. Sorry. And in this case, you can see here how the green points, they represent the use of the Pragmites australis. So additionally, that this plant increase the efficiency of the amoxicillin removal, we have a good removal of the toxicity. So continue, well, we work in other line related with the hemodialysis wastewater. This was very interesting because some industry and comment about this problem, because if you verify the statistics in internet in the different countries, increase the number of hemodialysis clinics. So this is the difference. Well, we drink Diet Coke or Coca-Cola, etc., and increase the problem in the different system in our body. So we verify which is the content of this wastewater, and the most important included the organic matter from the different fluids in our body. Additionally, we obtain different salts because it's not well, the body is not retain the good quantity of water. So accumulate the salts, and that's the biggest problem in this kind of wastewater. So we evaluate different surfaces to use it in electrocoagulation. Commonly, you can use aluminum on stainless steel. And comparing, we evaluate by spectroscopy impedance that increase more current with stainless steel. Additionally, we reduce the quantity of sludge, which is common to generate this kind of processes. Here you can see the difference image with how change the color of the water. If you observe the hemodialysis wastewater is apparently is okay, but the problem is the content of salts and the organic matter. So we integrate the electrocoagulation and the electrooxidation, and you can see here how reduce the chemical organic demand just close to the 13%, and reduce in with huge quantity the total suspended solids, 144 to 10 milligrams per liter. So the idea is to collaborate and to give our knowledge to the society. So we have the opportunity here in Querétaro with the Clínica Madrid. This clinic is private, but they very nice accept to integrate our system in their clinic. And you can see here how integrate the systems. We were down of the clinic and integrate this electrochemical reactor that I showed you before. And we evaluate, this is the NOM 003, is in Mexico, is related to reduce the wastewater in the same place. So here you can see how to reduce in close to the 18% of total organic carbon and chemical organic demand, and close to the 50% the total hardness and total alkaline and carbonates. And with these results, we evaluate the sludge, and they are not dangerous to reuse it. So now we evaluate how to obtain from the waste to a resource of this kind of sludge. We verify that only we have the sludge go directly to retain in some specific place, or to reuse and to germinate some plants. And here we verify the content. The most important was iron, magnesium, sodium. And we observe that we can use this kind of sludge to grow soja. So the soja increased the size, and the idea is continue with these experiments to involve other kind of plants to improve the soil quality of the different countries or in the same clinic. And well, this is now they are the projects that we are involved in the wastewater treatment. Other matrix was very nice for us because it's different to have an homogeneous soil. When you walk, each step is different the soil than of you. The difference with the water and the air is very easy to have a representative sample, because you maybe the 4 persons collect the air or the water, integrate, and you have a representative sample. But it's not the same with the soil. So using the soil and to increase the properties, we can grow some plants and the germination of seeds. And we support the goal number 2 to zero hunger. And the idea is when we verify the different methods to remove the pollutants from the soil, you can see here the most popular is the biological, is the more acceptable in the different countries. But there are other, the thermal, methods. The problem is when you use this kind of methods, change the properties of soil. You won't have soil, you will have waste. So this is a big problem. For that reason, we developed the electrochemistry in this kind of remediation and participate in the electrokinetic treatment involved with radionuclides and scintillation liquids, arsenic, sodium, mercury, and hydrocarbon. The last one is the most important in Mexico because we have different refineries in the different parts of Mexico. So increase the problem of the polluted soil. And the idea is to involve, as I showed you the slide before, increase and involve other wastes of other activities in the same soil. So about our results, we developed in our laboratory. This is a small quantity of soil. We use it as circular arrangement of electrodes. This is important because usually when you review the different processes related with this, use it only a couple of electrodes, an anode and cathode. But the idea was to generate the different methodologies to go directly to the field. So here you can see, you can observe the red color. They are the anodes, and in the center of this reactor was the cathode. It includes a space to remove the different ions, or in this case, the hydrocarbon, directly in this space with water. And later pumping the water and treat directly in the film. So with the first experiments, we obtained close to the 50% of the removal of hydrocarbon. And with this methodology, we go directly to the field, including and develop the in situ remediation. And this is very nice because with these results, we continue and go directly to the refineries. And we propose two methods. The first one, we can take it in a big car and to contain the cell and reduce the cost by the treatment directly in the cell. Or in some cases, in the refineries, there are different tubes inside of the soil, and it's dangerous to promote the electrokinetic because we promote the corrosion of these tubing. So, the idea to have a better soil in the end was to include the phytoremediation. In that occasion, we used a maize, bean, and wheat because they are basic for the Mexican people. And with these results, we have the opportunity to have a big project and involve the circular arrangement of electrodes in a serial connection and include directly in the soil. And only we stay with this treatment 1 week. Each day, we change this kind of electrodes and we promote the removal of the hydrocarbon. And we remediate close to that 1 hectare. So you can see here how after this electrochemical treatment, we include the maize and increase the size of this maize after 2 months. And that was very nice because in comparison of the other zone without this electrokinetic treatment, the maize is not, wasn't grow. And in this occasion, the maize was approximately 1 meter of the length. So we verify how we remove the hydrocarbon and the quantity was reduced close to the 100%. And for that reason, now we are working in biobarrier couple, well, reactive permeable biobarrier coupled with electrokinetic treatment. We used these ideas when we removed mercury here in San Joaquin. We had other projects. But now we want to include bacteria in the same place. So the idea, we began with some experiments, and the idea is to promote different reactions of material with hydrocarbons, promote absorption, transformation, Other idea is to promote the different electrokinetic phenomena. Is commonly to develop electroosmosis, electromigration, and electrophoresis of the same bacteria. And the last one is the biological processes related with this composition and the emulsification. So we are preparing two kinds of reactors. One of them was vertical, another is was horizontal, and we promote the remotion and include in this kind of barriers agave waste or the agave bagasse and nutshell. So these barriers were prepared with this kind of waste. And you can see how we remove the phenol is a model molecule from the hydrocarbons, and we remove close to the 100%. So we continue with this work, and well, I hope that in proximally we include with the real soil. And with these ideas, somebody comment to us, what happens if you don't have a polluted soil? If only you promote a different electrokinetic treatment, promote the different phenomena of transport to grow seed or grow plants. So we combine actually our modified surfaces with a biological stimulation. Here with other center of research in Guadalajara, includes different bacteria and integrate the electrical stimulation with biological stimulation. So combining both, we want to reduce the quantity of the agrochemicals, reduce the eroded soils, and increase the seed germination percentage. The crop profitability is important for the farmers and agricultural production, and increase the carbon dioxide capture. It's important because when we follow the Springfield of this kind of compound, everybody pay attention. And increase the cost and benefits ratio is important for the farmers too. And we have the experience to promote the growth of Arabidopsis thaliana, Lodium perenne with Spain, Echinocactus grusoni, Mammillaria matilde, both of them, they reduce the quantity in Querétaro. That's why it's an extinction species in Querétaro. And of course, CMAs and Triticum. So with these results, we obtain a good results. So now with an integration of the biological stimulation, we want to increase the production on different agri-food products, like blueberries and tomato. They are important in Mexico to the exportation. Here. So how we began this idea? Well, we began with Arabidopsis thaliana. This plant is very nice because in Spain is a cancer model. And we include a couple of electrodes, anode and cathode. And we promote the growth directly in a little scale. And after 40 days, we observe how increase the secondary roots. And this is important because in order of the specialists promote the retention of nutrients for the growth of plants, different micro and macronutrients for the plants. So we promote the growth of the Arabidopsis thaliana and increase the number of plants. Additionally, increase the different sheets, the large, the length of the plant. And with these results, we continue. And we worked with Cucumis sativus. And the cucumber is very important because they need a lot of water. So that's with this plant, we evaluate our processes. It's good for the new generation. We reduce the quantity of water in all the world. How to produce more plants for our life. So we integrate the same system, and was nice to observe how to increase the roots using the couple of electrodes that we use in the wastewater treatment. The same, the basic is to have iridium dioxide. Additionally, increase the different plants and move the different nutrient, micro and macronutrients to promote the growth. And the most important was to observe when we grow the plants, the insects didn't arrive when we promote the electrokinetic movement of the different micro and macronutrients. In contrast of the control system, arrived at insects and die some plants. So she is Professor Silvia. She developed this consortium of bacteria with Professor Iliana. I remember that she will be here tomorrow with you. And we integrate this system. You can see here some cables. And we develop the electrical stimulation and add the microorganism. Additionally, we have the opportunity to use the coconut shell, and is the semi-hydroponic system. And we develop and grow the blueberries. And comparing the different controls, we observe how increase the cumulative yield using first the electrical stimulation and later the biological stimulation. The idea is to have the free manner, the different ions, and the microorganisms take them to increase the number of roots and increase or grow in better manner the plants. So now we are running some experiments using tomato. And with tomato, we reduce the quantity of cables. And now we have this prototype. Here only we have a couple of electrodes, and it's like a shot of electrical shot. We change to each plant, and we increase the number and the different properties of the plants, increase the plant height, the stem thickness, the root length, the biomass, and of course, the production of the tomato. In comparison to different controls, we have the result that combining first the electrical and later the biological stimulation, we generate 2 kilograms per plant in 3 months, in contrast of the different controls. So it's important for us today. We are preparing some publications about that, but it's important to the production in Mexico. And the last one is the air. The air, we pay attention after the pandemic situation. We stay in our homes, and we have sometimes some polluted air on site. And that's why we integrate these experiments in the environmental electrochemistry to support the goal number 13, related to climate action. So when you verify the different treatment of the polluted air, you can find the control of or other control, reduce the particulate emission, noise control, radioactivity control, and emission gases. In this, we wanted to remove volatile organic compounds. It's commonly found in the different countries when you are in your car, when we are in some close of some industry, and we promote the absorption and advancing oxidation processes using the electrodes that I showed you before. With these processes, we remove the vitex, benzene, toluene, ethylbenzene, ethylene, and additionally, in general, the volatile organic compounds. And the idea is just to reduce the quantity of carbon dioxide in all the world. So we prepared the different processes. You can see here some photos of our prototypes. And the first one, we involve the activate carbon. We have an horizontal reactor. The second one, we integrate, like by the experience of the other matrices, we include electrodes in a concentric manner. And the last one, we include a photolytic system. Only we using ultraviolet light to remove the last pollutants after the first one. So when we evaluate each one in individual manner, we obtain close to the 50%. But when we connect in this manner, first absorption, later electrochemical system, and finally photolytic system, we arrive close to 100% of the removal of toluene. So this was our system in the laboratory here. And we are studying now the different intermediate reactions to verify how to destroy the different pollutants in the air, because it's important to remove the suspended particles on the air later to remove the organic compounds. So with this experience, this is now our prototype. We include the different systems, and we go directly to the UNAM in Mexico City and integrate this system to a gas chromatographer. This was very nice. The last year, you can observe here this tubing, include directly from a window in the UNAM. The polluted air go directly to the reactor, and later the products go directly to the gas chromatography. So we verify the products of reaction, and directly using this prototype to the polluted air, we observe that reduce the concentration of toluene and the other vitex close to the 50% directly with the real system. So now we are using some modified surfaces with titanium dioxide nanotubes, including lead and included iron, to promote the different oxidant agents like hydroxyl radicals. And additionally, we want to valorize different waste like chitosan. Chitosan we obtain of the shrimps, and it's important because when we use this kind of waste, we promote a better distribution of the iron and promote a more concentration of the hydroxyl radicals to the removal of volatile organic compounds. Additionally, we want to valorize lead from the batteries, because these batteries we observe in the different places is only in some place, but without some other action about that. And iron, we are using from the industry here in Querétaro. Different industries generate a lot of waste related with this kind of metal. So with iron, we want to include in the cathode, and with the lead, we want to include in the anode. So included, modify the surfaces and included in the prototype that I showed you in the slide before. So in the laboratory, we are now characterizing these modified surfaces, and we verified that it's important to have in titanium dioxide nanotubes the anatase and rutil. Is good to have and promote the photoelectrocatalysis. That's why we developed this, because we want to integrate directly the ultraviolet lamp inside of the electrochemical reactor. And we promote with this kind of modifications a good current or current density, which promote the destruction and the removal of volatile organic compounds, and with good stability in different time. So in conclusion, well, I hope that you enjoy with this presentation. We had different ideas to remove the pollutants from the air. And well, the idea is to integrate just basic science with innovation, with a modification of different surfaces. And with them, we develop some pilot systems to have finally some social appropriation in water, soil, and air, and to support and to continue with the integrate ideas in the circular economy, and support the goals number 2, 6, 12, and 13. And of course, integrate the waste. Now they are our results. And finally, I want to acknowledge them to the students. They are the students who are in the laboratory, in the different programs that I told you before, and my research group, and the different national and international institutions who help in different projects, and of course the different financial support to develop this kind of research. And finally, well, thank you very much and enjoy your step with.
It was an amazing talk. Do you have any question?
Yeah.
Perfect. First.
Hello, my name is Mar, and I just wanted to say first that I think it's really interesting that the research that you're doing is very important for the planet in general. And I wanted to ask you what were like the most, what was the most difficult part of your research? Like, what was the most challenging thing that you had to face when developing these prototypes?
Yeah, it's like the first talk. The most important is to obtain funds to develop the different projects. But actually, the most difficult for us is to integrate how to arrive with our different processes to the society. So actually, by the well, before the name was Conacit, now it's a city, and integrate the humanity. So how to connect with the society. So this is the second difficult for us, how to explain to the different persons how to integrate. This is maybe for me, well, that's the two fonts and the integration. Yeah, you're welcome. Yeah.
First of all, thank you for your talk. It was very interesting to know about other type of environmental solutions for pollutants. And regarding that, I didn't catch if the specific area of where the water treatment is being carried. I think it's here in Querétaro.
Yeah.
Yeah. Since it's like a super heavy metal rich water and like in other type of mineral not residues but like components,
Yeah.
Are there any possibilities of using bioaccumulating plants that
Yeah.
trap those metals
Yeah.
for like a filtration of water as well?
Yeah, yes. Thank you by your question because exactly when we use directly the phytoremediation, the different minerals arrive directly to the root of the plants. The idea to integrate this biological system with electrochemistry, we reduce first all the minerals by electrocoagulation. We precipitate fast in comparison of only coagulation, chemical coagulation of flocculation. And we reduce the quantity of the different salts and integrate only the slush. When we generate the wastewater treatment in the end, or after the electrochemical treatment, the quantity of the different salts is more nutrients for the plants. That's why it's important for us. Well, we demonstrate in different occasions the integration of the electrochemical and later biological is a good idea to have a good condition in the water to arrive to the plant. Yeah, yeah, I explained. Okay, thank you.
Hi, sorry. And I wanted to ask, like, how much does it cost to make all these systems? Like, are they very expensive? And in the example of the electric stimulation, you need to change the whole system because I think it might be damaged by erosion or the soil or something like that.
Okay, okay. Thank you by the question too. Well, in the case of the electrofarming, we change the manner that we include the electrodes in the soil. When our first experience in the field was with blueberries. So the idea in laboratory, we connect the different electrodes in Syria, and we arrive to the blueberries in the same way. We connect the different electrodes, the anodes, the cathodes, just in the lines of the farmers let us to work. And they told us, oh, sorry, but what happened with maybe 1 hectare of plants? You connect all the electrodes, you have a lot of problem because you have a lot of cables, maybe corrosion, cuts, etc. So with that experience, we have in mind how reduce that quantity of cables and electrodes. That's why now with Tomato is a new prototype. We integrate only a couple electrodes, anodes and cathodes. It's portable. So for each plant, stimulate 10 minutes. Apply 2 volts per centimeter is the separation of the electrodes. And the people generate the electrical shock. And, so continue with each plant. And after this electrical stimulation, continue with the addition of the bacteria. In the field, it's commonly that this kind of stimulation is plant by plant, the addition of the bacteria. So only now we are adding the electrical stimulation first to promote the liberation, well, the free ions between the different spores of the particles of soil. And with the electrical stimulation, separate the particles of soil. And in the pores, stay the different ions. So when arrive the bacteria, they take these ions and promote the growth or number of bacteria and go directly to the root. So increase the growth or the number of plants and the different biological characteristics of the plants. Yeah.
Hi. I wanted to ask, out of the soil, the water, and the air, which one do you think represents like the most challenges?
Thank you for the question. Why? I began in electrochemistry because I worked before in bioremediation in the soil before I studied a master's degree and PhD. And I observed that the biggest problem of the bioremediation, sorry if there is somebody that working in bioremediation, but only in my experience, I observed that you need a lot of months to increase the number of bacteria and to remove the pollutants. You need to add nutrients and different processes. And I read different papers related to electrokinetic treatment of Netherlands or Canada and Germany, different countries. So I read that papers. And that's why I imagine how to include the electrodes to promote the remotion of the soil. So that's why is the soil. As I told you before, it's very different. Some area of the soil, of other part of the soil, in comparison of the water and air. So the most difficult was to think how to remove the pollutants from the soil in comparison of the water and air. So why is important soil? The specialists who study edaphology, they remember everybody that it's important to grow or to increase the quality of soil because the soil promotes the different nutrients and retain the water. So if retain the water, we have a stabilization of the temperature in all the world. And if we want to obtain 1 centimeter of soil, we need 1 year. If we promote a better quality of soil, we can have in the future better quality of water and better quality of air because it's a cycle. The planet is a cycle that all the pollutants go up, down to the soil. That's why it's the most important, I suggest, to work in the soil to have better properties of the water and air. I hope explained. Okay. Thank you. Yeah.
Well, hello. I think this was a very interesting conference, but I want to ask, like, in the technique in which you already applied your water treatment process, that 30% in which you told that they will have like very economic profit, did they already see it, or is it like a prediction?
Yeah. Yeah, it's a reality. Fortunately, I verified the top 10 of the clinics in Querétaro. I made the calls. Who of the clinics help us to go with the wastewater treatment? Fortunately, the first one was Clínica Madrid. And we integrate and develop the different processes after the laboratory, with the best conditions. We prepare directly in the clinic. We stay only 1 week. So we evaluate the different parameters, and that parameters with a real system, we take it to the GPS program and simulate. That's why it's very interesting, that program, because you simulate the real conditions and evaluate the efficiency of the removal of the different pollutants and verify the cost. So with the real parameters, we integrate and simulate with this program, and we evaluate and prove to the clinics that they reduce a certain percentage of the difference costs of the water that they use for the hemodialysis treatment. Because they need, sometimes they buy some pipes of water to develop the difference hemodialysis treatment. So if they integrate this plan, the idea is to reduce the consumption, maybe in the service, on other activities, secondary activities of the hemodialysis treatment. Yeah, you're welcome.
Hello.
Yeah.
I wanted to ask you regarding the use for the growth of plants. My first question is, what do you use as a positive control to know that they actually grew more than they are supposed to? And also, how efficient would it be to actually apply that to bigger crops, since you said that you have to apply the electrical current plant by plant?
Yeah.
So how could you apply that to bigger crops?
Yeah. We combine the electrical and biological system. It's the best for us. And our controls were separate, only the electrical stimulation without addition of bacteria. Other control was the contrast, only bacteria without electrical stimulation. And other control was only soil without any treatment. So we compare the different characteristics, the same characteristics for all the different systems. And additionally, we include first to promote the biological stimulation and later the electrical stimulation. So we compare all the system. And for that reason, just I can comment that is the best, the combination, the electrical and later the biological. We verify just the first day the different properties of the plants. We verify the length, the number of sheets, the color, the Britex measure is for the contain of the organic matter and other components directly in the plant. And we evaluate the soil too. We verify the anions, cations, the micro and macronutrients, and the microorganisms. So with these controls, we follow during 2 or 3 months how grow the plants. And when we include the different stimulation, is commonly in the field to integrate the electrodes close to the plant. That's why we didn't interrupt the different growth of the plants. I explain? Or yeah? Okay.
Thank you.
You're welcome.
Hi, I wanted to ask you, like, if it's possible that the electrokinetic treatment may affect the microorganisms in a negative way.
Yeah. If we, electrokinetic treatment is for the polluted soil, and the electrical stimulation is for the electrofarming. Is maybe it's resemble the concept, but it's different. Why? Because in the electrokinetic treatment, we work directly in the electrochemical interface. We need to verify how to arrive the pollutant over the surface and transform this pollutant with the hydroxyl radicals, for example. When we apply only the electrical stimulation in the electrofarming, we promote the different ions, the migration of the ions, and the change of pH. So when we use the iridium dioxide, we promote the hydroxyl radicals. Additionally, increase the acid pH close to the electrode. With the acid pH, we promote the migration and the solubilization of the nutrients. So when later if we apply the microorganisms in the case of the electrofarming, they take these ions to grow. In the case of the electrokinetic treatment, we evaluate the bacteria and fungus that we have in the same polluted soil. And we observe that depends of which is the PK of the, for example, bacteria or fungus, depends of the migration. This is the third step of the electrokinetic treatment, is the electrophoresis. So it's some micelles, and including the microorganisms, can move it between the electrodes, but the charge that they have. So they, because somebody told us, you killed the bacteria when you apply your electric field. No, because it's very low, the quantity of energy that we use in volts. We use it close to the 2 volts per centimeter. It's the separation of the electrons. It's very, very low. When we have the electrical shock, is huge, the quantity of volts. So only we promote the mobility of the microorganisms, the nutrients, and that's why we promote the growth of the bacteria and fungus in between the electrodes, and clean too the soil. Yeah, you're right.
Thank you all for all your amazing questions. We don't have much time for more questions, but if you have any more, you can ask Dr. Bustos outside, or you can send her an email. So please, from part of the committee, the school, and our sponsors, we have a small gift for you.
Thank
Professor.
you. Thank you so much.
And let's take it, right?
Thank you so much. Thank you so much.
Thank you all for coming. We invite you to come to the next talk by Dr. Ale Prieto about synaptic memory coding. Thank you all. Tenemos la doctora.